In the early 1900s, polio stopped behaving like a rare medical curiosity and started acting like a modern epidemic. Year after year, more towns reported clusters of sudden paralysis, often in children who had seemed healthy the day before. The timing felt cruel and random. A fever, a stiff neck, then an arm or a leg that no longer worked. For families, it landed as shock. For doctors, it landed as a question with no clear answer. Medicine still did not know what truly caused polio, and that ignorance shaped every response. Some believed it spread through bad air or summer heat. Others blamed contaminated food, insects, or dirty streets. Cities tried to act anyway because doing nothing felt impossible. Public pools closed, travel was discouraged, sick children were isolated, and neighbours watched each other with suspicion. Yet cases still appeared, sometimes in places that followed every rule. Control measures kept failing, and fear kept rising. Polio also broke expectations about who should have been safe. It hit children in ordinary homes, including families that took pride in cleanliness, and it struck in waves that seemed to follow no map. Doctors treated symptoms because they had nothing else. They supported weakened breathing, splinted limbs, and waited to see who recovered and who did not. Each outbreak left survivors with lasting disability and communities with a new reality. Childhood no longer felt automatically protected. Researchers stopped treating polio as a strange kind of paralysis and started hunting for a specific cause. In laboratories, they took material from patients and passed it through filters that trapped bacteria. The illness still spread. That result pointed to something smaller than any bacterium, a virus. Once poliovirus existed as an idea, the problem changed. Polio became a target with edges, not a mystery without limits. But naming a virus did not solve anything if nobody could prove it was there. Scientists needed reliable ways to detect it, compare samples, and follow its path. They used animals to see whether a suspect sample caused the same kind of paralysis again, and they learned to track the body's response by measuring antibodies in blood. Those tests turned outbreaks into data. They separated look-alike illnesses from true polio. With those tools, researchers mapped patterns that had been invisible before. They identified different strains of polio virus, and they saw that many infections caused no paralysis at all. That mattered because it explained how the virus spread quietly and then struck without warning. Step by step, polio shifted from an unpredictable disaster to a definable viral enemy that could be measured, studied, and finally approached with prevention in mind. After the big outbreaks of the 1910s through the 1930s, polio stopped feeling like a rare tragedy and started acting like a repeat threat. Families learned that a healthy child could weaken in hours, then lose the use of a leg, an arm, or the muscles needed to breathe. Communities answered with the tools they had. Quarantines went up, swimming pools closed, travel got restricted, but none of it reliably stopped the next wave. Hospitals shifted into emergency mode. Wards filled fast, and staff had to make rapid decisions for patients who could not move or could not draw a full breath. Mechanical respirators, including the iron lung, became a lifeline for those whose chest muscles failed. It kept people alive, but it also turned survival into a new problem. Patients could remain trapped in machines for weeks, sometimes longer, while families waited and hoped for any sign of recovery. Then came the long aftermath. Children who lived through the acute infection often faced months of weakness and uneven paralysis. Doctors and therapists pushed new rehabilitation routines, splints, braces, and carefully timed exercises to prevent deformities and recover whatever strength remained. It helped, but it did not erase the damage, and it did not prevent the next season's cases. Polio became a public health crisis measured in beds, machines, and lifelong disability. Prevention started to look like the only real exit. In the 1940s, polio research hit a wall that had nothing to do with ideas and everything to do with supply. Scientists needed huge amounts of polio virus to study it and to test any vaccine. But the virus did not grow easily on demand. It often required living animals, and even then, yields stayed small, slow, and expensive. That bottleneck kept vaccine plans stuck on paper. Then, a practical breakthrough arrived: human tissue culture. Instead of chasing the virus through animals, researchers kept living human cells growing outside the body in carefully controlled conditions. In that setting, polio virus multiplied. It meant the virus could be produced in a repeatable way, batch after batch, without relying on scarce animal material. For vaccine makers, that changed the problem from impossible to manageable. Once polio virus could be grown this way, the whole pace of work shifted. Scientists could run more experiments, compare results, and measure how different preparations behaved. Most importantly, they could finally imagine producing enough virus to make vaccines for millions of children, not just for laboratory tests. The question stopped being whether a vaccine could be built at all. It became how to build it safely. Jonas Salk entered the race with a simple, hard promise: protection without risk. Instead of trying to weaken polio virus and hope it stayed harmless, he aimed to kill it completely, then use it to train the immune system. The idea sounded safer, but it raised a brutal question. If the virus was truly dead, would the body learn anything? Everything depended on getting that balance right. Salk built his program around careful steps. He grew poliovirus in large amounts, then treated it with chemicals meant to inactivate it while keeping its outer shape intact. That outer shell mattered because the immune system recognized shapes, not intentions. Too little inactivation meant danger. Too much meant a useless vaccine. He tested and retested, looking for proof that no live virus remained, then measured whether antibodies rose. Early human testing began small and cautious because the stakes stayed personal and immediate. The vaccine went first to adults and closely monitored volunteers, then moved forward as signs of immunity appeared without signs of polio. Each round answered one fear, then exposed the next one: consistency, dosing, and how long protection lasted. But for the first time, a credible path opened. Immunity created on purpose, without causing the disease. By 1954, the question was no longer whether a polio vaccine sounded promising. The question was whether it truly worked in everyday life. So the test became enormous, spread across real towns and real schools, and built around a simple idea. Compare children who received Salk's vaccine with children who did not. Then watch what happened when polio season arrived. Millions took part. The country treated it like a national mission. To make the results trustworthy, the trial followed strict rules. Records had to be accurate, diagnoses had to be checked, vaccination had to be tracked dose by dose. Public health workers, doctors, and volunteers carried the weight of it because one mistake could blur the answer. Then came the waiting, as communities moved through months when polio usually surged. This time, instead of only fearing the virus, people measured it. In 1955, the numbers landed with force. The vaccinated children developed far less paralytic polio than the unvaccinated. Effectiveness was no longer a hope or a lab claim. It was demonstrated in the open, at national scale. The response moved fast. The vaccine received licensing, production accelerated, and the country erupted in relief. For many families, it felt like a door finally closed on a nightmare that had stalked every summer. The vaccine rollout moved fast, and millions of children received the new shots. Factories worked at full speed, and the country expected polio to start fading. Then an unexpected pattern appeared. A small number of children developed paralysis soon after vaccination. The timing felt impossible. The vaccine had been designed to contain dead virus, unable to cause disease, yet something had gone wrong, and the promise of safety suddenly looked fragile. Investigators traced many of the cases to doses made by one manufacturer, Cutter Laboratories. The problem was simple and terrifying. Some vaccine lots had not been fully inactivated. Live polio virus remained in the vial, and it entered the bodies of healthy people. Some recipients became paralyzed, others carried the virus and spread it to family members. In a campaign meant to stop an epidemic, the product itself briefly became a source of infection. The response was immediate. Vaccinations paused while officials reviewed how every batch had been made and tested. The incident forced a new era of regulation. Stricter standards for manufacturing, tighter inspection of factories, and clearer rules for proving that inactivation worked every time. Oversight shifted from trust to verification. The Cutter incident did not end vaccination, but it changed it permanently, turning vaccine production into a tightly controlled public health system. After the first vaccine arrived, the goal still sounded simple: protect each child one shot at a time. But one scientist pushed a different idea. Albert Sabin developed a live attenuated polio vaccine, made from virus that had been weakened so it trained the immune system without causing the full disease. And he delivered it by mouth. No needles, just drops. It promised speed, scale, and a new kind of reach. Sabin's approach did something the injected vaccine did not. Because the weakened virus grew in the gut, it built strong defenses right where polio virus first entered the body. Then it sometimes passed to close contacts through everyday hygiene failures, quietly vaccinating others as it moved. That sounded risky at first, almost like inviting the enemy inside. But in trials and campaigns, the effect became clear. Whole neighborhoods gained protection, not just individuals. That changed the strategy. The question stopped being only whether one child avoided paralysis and shifted to whether the virus got trapped with nowhere left to travel. If the vaccine could block infection and spread immunity outward, it could interrupt transmission itself. Public health planners now weighed two tools with different strengths. One focused on individual protection, the other aimed at shutting down circulation in the community. The race moved from prevention to elimination. By the 1960s, polio stopped behaving like an unavoidable part of childhood in many places. Health officials stopped waiting for summer outbreaks and started running vaccination campaigns on purpose and at scale. Schools, clinics, and community drives delivered doses fast year after year until immunity piled up. The change showed up in the simplest measure. Case counts fell hard. Wards that once filled with paralyzed children no longer did. As coverage widened, the pattern of the disease changed. Polio needed chains of infection to keep moving, and mass vaccination cut those chains in everyday life. Outbreaks that once spread across cities now fizzled or never began. Parents who grew up fearing the virus watched younger children pass through summers without the same threat. Public health gained a new kind of confidence. A disease that had seemed permanent started looking beatable. That success pushed the goal even further. If vaccination could drive polio down country by country, then coordinated effort could drive it down everywhere. Campaigns expanded beyond routine clinic visits into planned, repeated immunization rounds meant to reach every child, including those missed the first time. The target shifted from control to elimination, then to eradication. In many countries, polio turned into a memory, measured in years since the last case. By the early 2000s, polio had been pushed to the edge of the map. In most countries, parents no longer expected a summer of sudden paralysis. Hospitals no longer filled with children who had stopped walking overnight. Case numbers fell so low that some places treated polio as finished. Yet the virus did not need many chances. It only needed one chain of missed vaccines to start moving again. The last strongholds sat in limited pockets where vaccinations stayed uneven. Conflict disrupted clinics. Remote regions stayed hard to reach. Misinformation slowed uptake. In those gaps, the wild virus kept circulating quietly person to person. And another threat appeared alongside it. In under-immunized communities, the weakened vaccine virus sometimes spread long enough to change and regain the ability to paralyze, creating new outbreaks where polio had disappeared. That reality reshaped the end game. Success depended less on new science and more on doing the basics everywhere, all at once. Surveillance had to catch every hint of circulation. Rapid vaccination drives had to close every opening. Countries that had been polio-free still faced imported cases and sudden flare-ups when coverage slipped. The world had come far from routine childhood paralysis, but the finish line stayed unforgiving. Gaps meant return.